Ever since the last glacier formed Cape Cod 20,000 years ago, the Atlantic Ocean has worked to take it away through the process of erosion. Where's the best place to look for the process of erosion? The beach, of course. Welcome to Cape Cod National Seashore. We're going to be starting our erosion unit today. If you remember, when we were at Dome Rock, we were talking about weathering. Weathering is the breaking down of rock over time from larger pieces to smaller and smaller pieces, usually in one place. Today we're going to talk about what happens to those pieces. Sometimes the pieces are called sediment. And once that sediment forms, it doesn't just stay there, it can be moved, and it's moved by the process of erosion. And so that sediment is going to move, and usually by the wind and water. A beach has a profile, just like a person. It is a sideways look at the parts of a beach. The position, size, and composition of each of these parts will determine how vulnerable the beach is to the process of erosion. Let's catch up with Ranger Dan and look at the parts of a beach profile. The first part of the beach that we'll be talking about is the foreshore. This is the part of the beach that is closest to the water. It is also the part of the beach that is covered with water at high tide and exposed during low tide. Now Ranger Dan is moving to the next part of the beach. Ranger Dan is standing on what is called the berm. The berm is a terrace-like structure that runs parallel to the water, and it's a higher point in the sand, usually formed by the waves coming in and out. Sometimes it can be very steep if there have been some big waves. Oftentimes in the summer it's relatively shallow. Ranger Dan is now going to move to the backshore. Ranger Dan is now standing on the backshore. This is the part of the beach that is furthest away from the water. It is normally only underwater at extreme high tides or during a storm. The backshore of the beach is where you could safely put your beach blanket if you were going to the beach. Ranger Dan is now going to move up to the marine scarp or the marine cliff. The marine scarp is left behind by the glacier, and it contains a mixture of large and small sediment particles. You can see by looking at the picture that a lot of the parts of this marine scarp are sliding down onto the beach. The sand and sediment in the scarp actually replaces the sand and sediment that is washed away from the beach during the process of erosion. Besides water and waves, wind can also move sediment and sand. Most of the dunes that you see on Cape Cod are formed by wind-blown sand. Dunes are mounds or hills of sand. They form from wind-blown and water-transported sand. The dunes protect the land behind them from high-energy ocean waves and are a habitat for many coastal organisms. During our summertime, we have relatively small waves because we do not have that many big storms. Small waves have a tendency to bring sand up onto the beach. Large waves that we have in the wintertime due to our large coastal storms take sand off the beach and cause erosion. How much sand can be removed from the beach due to erosion? Ranger Dan is going to do a demonstration for us. The average rate of erosion on this beach is about 4 feet a year. So where was the marine scarp when the average fourth grader was born 10 years ago? So Ranger Dan is going to pace out 10 4-foot steps and see where he ends up on the beach. Walk out 10 steps. Ranger Dan, turn around and look back at the cliff. Ranger Dan turns around and looks back at the SCARP. All of that between Ranger Dan and the SCARP has been taken away by erosion. Where Dan is standing, that would have been the toe of the SCARP 10 years ago. That's a lot of sand. Where does it go? It goes into the ocean. Let's try another demonstration so we can visualize how the waves are actually moving the sand. Ranger Dan is going to take a bucket of sand and he's going to dump it in the splash zone. That's where the waves are breaking. And we're going to see how many waves does it take to move all of that sand that Ranger Dan is dumping. There was one wave. A lot of it's already gone. Second wave. And it's hard to tell where that bucket of sand was. The waves continue to take away sand from the beach year after year. But why is there always still a beach there? Well, the sand and sediment in our marine SCARP slides down onto the beach and replaces the sand that is taken away by erosion. The SCARP is actually where we store the beach for the following year. This picture is a photograph taken of the Nauset Light at Nauset Light Beach. Where the arrow is where the lighthouse used to be in 1996. Now the lighthouse has been moved back to protect it from falling onto the beach. After the sand leaves the beach, some of that sand is going to travel parallel to the shore in something called the longshore current. Longshore current is caused by waves hitting the beach at an angle. So they wash in at one angle and wash back out at the opposite angle, and it creates a current of water parallel to the beach. It's very difficult to see a current of water when it's surrounded by water. So how do we know that that longshore current is actually there, and how do we know which direction it's going? So Ranger Dan is going to help us with another demonstration. Ranger Dan is going to throw a grapefruit into the water, and the grapefruit will float, and the longshore current will move that grapefruit either north to Provincetown or south to Monomoy along parallel to the coast. So let's see which direction our grapefruit is going today. And it appears it is going north today, towards Provincetown. The longshore current today is not very fast because the waves are relatively small. If there had been larger waves, that current would have been faster along the shore. And sometimes, depending on which direction the waves are hitting, like I said, it could go to the south as well. This is a satellite image of Cape Cod, and it shows the general direction of longshore transport around the outer beaches and north, obviously, to Provincetown. And matter of fact, that's how Provincetown was formed. When the glacier first formed Cape Cod, Provincetown did not exist. Provincetown is a result of longshore transport carrying sand and depositing it at the end of the cape, causing that hook. Sometimes the longshore transport goes south, and that drags the sand along and actually formed the island of Monomoy, south of Chatham. In this image off of Race Point Beach, we can see the discoloration in the water. That's sand being carried along the tip of Provincetown. Cape Cod is always in a constant state of change. Ever since the Cape was formed 20,000 years ago, the process of erosion is taking it away. The Cape is always changing.